Alright, so in the video today we're going to be looking at the review for test 1. So if you haven't printed that out, it looks like this. You need to go print it out. Okay. I will also be sending you a key, but I wanted to make sure that I worked through all of these answers. So make sure that you pause the video and go grab that review if you don't have it out already. First of all, make sure you actually read over this first page. This first page is just kind of like a summary of everything that I want you to be able to do. So it's like, do I know how to plot points in a coordinate plane? Do I know how to find the distance between 2 points and blah, blah, blah. Okay, so you just kind of go through the list and be like, I'm confident with that. Maybe I need to work a little more on that. Okay, go through and make sure that you kind of read over that list. Okay, but essentially remember that you practice for math. You study for math by practicing problems. Okay, so you're going to need to, for sure, more than just reading over that general overview, you will need to make sure you look at the problems too. So this is going to be the test 1 review. Okay, so the first thing is, unlike your high school classes, you're going to have to make sure that you know formulas. Okay, so for number 1 and 2, you need to make sure that you know that the distance formula is the square root of the difference between the x's squared plus the difference between the y's squared. And then you're also going to need to make sure that you know that the midpoint, which is actually a capital M, is going to be the average of the 2 x's, comma, the average of the 2 y's. Okay, so let's get to it. So for number 1, we want to find both the distance and the midpoint between these 2 points. So for distance, we're going to do the square root of the 2x values subtracted from each other. So this is going to look like 4 minus -1 squared, and then plus -2 minus 8 squared. Make sure you watch your signs, probably the number 1 mistake that people make on a problem like this. So it's 5 squared plus -10 squared, but when you square either a positive or a negative answer, remember that you should get a positive result. So you end up getting 25 for 5 squared, and then -10 times itself would be a positive 100. So you get positive 125. Okay. So remember, Connect wants you to simplify answers. If you were to put this answer on test 1, I would give you most of the credit, but I would just count off just a bit, maybe like a point, because you didn't simplify. In other words, remember your calculator will do this for you if you bought the calculator I strongly suggested that you buy. But if not, you just break 125 into 2 factors, one of which you can take the square root of. Notice I can take the square root of 25, but not the 5. So the square root of 25 is 5, and then the square root of 5 has to stay put. Okay, so that is the answer I'm looking for, not a decimal equivalent or a decimal rounded version. I want to see the exact answer, which looks like that. All right, so for midpoint, make sure that in the end it looks like a point. In other words, it needs to be an x comma y. But just work each one of them separately. So this would be 3 over 2. Okay, this would be 6 over 2, which reduces to 3. Okay, so that's all for number 1. Number 2, same thing. It's just obviously these are a little more challenging of x's and y's. So for distance, we are still going to do the distance between the x's squared plus the distance between the y's squared. Notice it's a little tricky when it's negative, right? So the formula has a minus in it, so it becomes minus and negative. So don't overthink this, or try not to. 3 of something, take away 1 of something is just 2. So 3 square roots of 3, take away a square root of 3 is going to be 2 square roots of 3. Same thing here, this is going to change to a plus. So 4 of something plus 1 more would be 5 of those things. I forgot to square it here. So it would be 5 square root of 6, parentheses squared. So I know this is a little stranger, but just square each part. In other words, square the 2, square the square root of 3. Okay, so 2 squared is 4, right? Think about what the square root of 3 squared is. Square root and square undo each other, so you just get 3. In other words, if you want to think of it, it's like the square root of 9. Well, the square root of 9 is plain old 3. Okay, same thing here, square the 25. or sorry, the 5, which would be 25, and then if you square the square root of 6, it's just plain old 6. So you end up getting 12 plus 150, which is the square root of 162. And again, you'll want to give a simplified answer here. So 81 goes into 162 twice. And notice 81 is a perfect square. So we take the square root of 81 and we leave the 2 alone. Okay, but remember your calculator, the TI scientific calculator that I had you buy will also do this simplification for you if you want it to. All right, midpoint. Oh, we're not done with that yet, right? We still need to do the midpoint for number 2. So it's square root of 3 plus 3 square roots of 3 over 2, comma, negative square root of 6 plus 4 square root of 6 over 2. Make sure you use parentheses and a comma, okay? So we're going to get 4 square roots of 3 over 2 for the x term. And we're going to get negative 1 plus 4 of those would be 3 square roots of 6 over 2. Okay, we're going to simplify what we can. In other words, this 2 can cancel out with this 4 and leave a 2 there. Notice 3 and 2 can't simplify though. So I know it's strange and I know you may not love it, the format of it, but it ends up looking like this for the midpoint. Okay. If it makes you feel any better, I tend to stick with kind of the most basic problems on the test. So you would more likely see one like number 1 than you would number 2. Okay, but number 2 is still worth knowing how to do. Okay, so let's look at 3 and 4. Find the x and the y intercepts. Okay, remember to find the x-intercept, you set y equal to 0. So it doesn't really equal this. So whenever you want to find either intercept, you set the other thing equal to 0. So for 3, we've got the equation negative 3y plus 4x equals 6. So on your test, I want to see where you did the work. Okay, I want to see where you knew that, hey, I need to set the y equal to 0, and then where you did it. So negative 3 times 0 plus 4x equals 6. So I end up getting 4x equals 6. And then if I divide by 4, I get x equals 6/4, but 2 goes into both 6 and 4, so that reduces to 3/2. Almost always I'm going to want you to write it as a point. Okay, and on the test, if I want that, I'm going to specify that, but yeah, I want you to write that as a point. For the y-intercept, we're going to set x equal to 0. So we're going to have negative 3y plus 4 times 0 equals 6. So negative 3y equals 6. And then we'll divide both sides by negative 3. So y is equal to negative 2. So this is the point 0 comma negative 2. Okay. Notice these were this was a linear equation, so we would expect that there would only be one of each x and y intercept, okay? As opposed to number 4, which is definitely not linear. So we might expect more of a curve going on, in other words, maybe more intercepts than we're used to, but the process is still the same. To find the x-intercept, we're going to set x equal to 0, or sorry, y equal to 0. So we're going to get negative 0 plus 49 equals x squared. Okay, so we end up getting 49 equals x squared. Make sure, I feel like most of you know that, hey, I need to take the square root of both sides. But when you do, make sure you remember that it's actually 2 answers, the plus and the minus version. So I'm going to rewrite this, but you end up getting plus and minus 7. Okay, and you need to make sure you get that that's actually 2 points. So that is actually the point 7 comma 0 and negative 7, 0. Okay. For the y-intercept, we set x to 0. So notice this is going to be the easier of the two probably, because the squared goes away this time. So we get negative y plus 49 equals 0, but we want y by itself. So what I'm going to do is just add y to both sides so that the y will be positive. And I'll end up getting 49 equals y, or y equals 49. At any rate, we want to write that as a point, so it's 0 comma 49. Okay. All right, so number 5, determine if the ordered pair is a solution to the equation. Okay, and so here is the equation we're looking at. 4 absolute value of x minus 1 plus y equals 18. Okay, so the first one, I'm going to do these kind of horizontally here. So -3, 2, and then 5, -2. Okay, so remember, if an equation is a solution, then it should work when we plug it in. Okay, so the real question I'm asking you is 4 times absolute value of -3 minus 1, notice I plugged in my x value of -3, plus my y value of 2 equal to 18. Okay, and I'm putting a question mark there because I don't actually know if it's true or not. That's actually what I'm trying to determine. So let's work it out. So we would need to actually figure out what the inside of that is. Consider the inside of an absolute value like a parentheses. So notice this would be a positive 4, so this is going to be 4 times positive 4, or 16, plus 2 is 18. Okay, so notice this checks out, which means yes, it's a solution. Okay, so let's try this one. So the question really is 4 times absolute value of 5 minus 1 plus -2 equal to 18? Okay, so same as before, we'll do the absolute value part first. So it's 4 times the absolute value of 4 plus -2 equals 18. Notice that's going to give us 16 plus -2 equals 18. It's close. If this were a positive 2, it would have worked. But notice this doesn't work, right? So not a solution. So on a question like this on the test, you can answer yes or no, but make sure you have a little bit of work to back it up. Okay. All right, so number 6, if you look at your review, this has a kind of table that I don't want to duplicate, so we're just going to kind of write down the answers. So remember that the domain is the x values, so if you are listing values, then you have to use a curly brace. So the domain is literally all the athletes' names. So I'm going to be lazy here. I'm going to say ... Okay, you'll have it on your key, but just know you would actually need to list them all out. Okay, so you would need to have, anytime you have a list, make sure you have them separated with commas and then the curly brace. Okay, range, remember, is the y values. So again, we're going to list them. So it's 12, 10, 6, and 28. Notice interval notation wouldn't be appropriate here because we're not going from something to something else. We're just listing these specific 4 values. Okay, and then lastly, is the relation a function? And the answer is yes, it is. Okay, notice no x is repeated. And remember, it's okay for y to repeat. It'll still be a function, but x can't repeat. In other words, you don't have a name listed twice. Okay, because the athletes' names are what the x values are, and we don't list like Carl Lewis twice, for instance. Okay. All right, so for number 7, make sure you know the vertical line test. Okay, in other words, a vertical line should only hit the graph once. So I'm just going to say should only cross the graph once if it's going to be a function. Okay, so notice that for A, the answer is no, right? If you look at this, I'm going to slide this over. You would definitely have a vertical line that could hit the graph more than once. In fact, 3 times if you hit it just right. So that's a no. But then notice this curve, no matter where I slide my vertical line, picture my pin as a vertical line, notice it'll only hit it once. So, so this fails the vertical line test. And this passes. So on the test you might be asked, is this a function, yes or no, and then maybe why? Okay, and the why would just be a brief description on whether or not it passes the vertical line test or not. All right, so moving along. Number 8, we have this function, which later on we learned that is a quadratic function, right? That would be a parabola if we graphed it. Not that you have to know that in this problem, but you will have to know that for this test. So notice anytime I ask you for f of something, it just means go to the f equation and replace the variable with whatever's in the parentheses. Okay, so in the case of the last one, which is probably the most challenging, that's all we need to do, right? Whatever's in the parentheses, just insert it in or plug it in, substitute it. So negative 2 times 0 squared plus 4 times 0. The first one I plug in 0 and I get 0. Okay. Make sure that you know, we're not going to do this for everyone, but make sure you get that this is actually the y value when x is 0. In other words, f of whatever means the y value. Okay, that'll help us on later questions throughout this review and on the test. Plug in a negative number. Just make sure, it's a good rule of thumb to plug in negative numbers inside parentheses, because you need to make sure that you do exponents before you try to multiply the negative 2 times the negative 1. You should actually be doing the negative 1 squared. And negative 1 squared is a positive 1. And then you can go through and multiply, right? So I get negative 2 plus negative 4, which is negative 6. Okay? So remember, that means this is the y value when x is negative 1. Okay, what about f of 3? So negative 2 times 3 squared plus 4 times 3. So again, we want to do exponents first. So negative 2 times 3 squared, which is 9. And then we'll go back and do the multiplications. So we get negative 18 plus 12, which is also negative 6. Okay. By the way, remember, that doesn't make it a function, or that doesn't make it not a function, rather. We repeated a y value, but we did not repeat an x value. Okay. So f of t just means go to your x or f equation and replace x with t. And then clean it up the best you can. So it's just going to look exactly the same as the original, just using the letter t instead of the letter x. Okay, so no big thing on that one. So the most challenging one is the last one. Okay, so we do negative 2 times x plus 4 parentheses squared plus 4 times x plus 4. So we've had problems like this several times in this unit, but just make sure we remember that we have to FOIL this x plus 4 squared. We're not allowed to just say, oh, that's x squared plus 16. You're not allowed to do that. Okay, we have to FOIL, and my suggestion would be to FOIL first and then worry about that negative 2. So if you FOIL, you're going to get x squared plus 4x plus another 4x, which is 8x. 4 times 4 is 16. And then I can use distributive property. The negative 2 would go to all three of these guys, and the 4 would go to both of these guys. So we get negative 2x squared minus 16x minus 32 plus 4x plus 16. And then add like terms. So we get negative 2x squared minus 12x and then minus 16. Okay, notice I combined the 16x or the negative 16x plus 4x, and I combined the negative 32 plus the 16. Okay. Okay, so number 9. Again, I don't want to have to redraw this, so this is what the graph looks like, okay, if you've printed this out like I hope you have. So we're just going to run through a list of all kinds of things that we can determine from this graph. So the first one is the domain. Okay, so if you look at that graph, with domain, we only care about x values. So we begin at an x value of negative 3, and we don't include it, so we use a parentheses because of that open circle. But then we continue on forever to the right, so that's how we write forever. We use infinity. Okay, for the range, if you look at that graph, we only care about the y values, right? So we go bottom to top. Notice the bottommost y value is 1, but this time I'm going to use a bracket because it's not open, it's actually including 1. And then again, it goes up forever, so it'd be infinity. Okay, make sure you know how to do domain and range with different looking graphs, okay, because you're probably going to have a different looking graph. It's not going to be this exact shape on the test. You're going to have to make sure you could do some different looks to it. Part C, where is the graph increasing, decreasing, and constant? So I'm going to abbreviate here. It's decreasing first, and remember we only care about x values. So it's decreasing from negative 3 to negative 2. It is constant for a bit from negative 2 to 2. Okay, remember these are not points, these are intervals. So it's from negative 2 to 2, that's how we write that. And then we are increasing from 2 forevermore, so 2 to infinity. Okay. Remember, we only use x values for decreasing, increasing, and constant, and we only use parentheses because the turning points could technically be considered part of two different versions of the graph, or two different parts of the graph, I should say. So in other words, we don't include -2 on either the decreasing part or the constant part because it could be part of both. Okay. All right, so for parts D and E, if you don't know what this is asking for, you can look at it for a really long time and probably not be able to determine what the answer is. Okay, so remember, for both of these, what you're being asked to find is what's the y value when x is whatever. Okay, so the first question is what's the y value when x is -2? We'll look at that graph, right? The y value when x is -2 is 1. Okay, so I'm going to write that out. This is the y value when x is -2. Okay, so same thing on f of 3. Okay, what's the y value when x is 3? Notice the y value looks like it's 2. If for some reason you're asked to find the y value and it happens to be an open circle, remember we call that undefined. Okay. All right, f. Find all x for which f of x is equal to 3. Okay, so in other words, f of x or y is equal to 3. That's what it's telling you. Okay, so you go to your graph and you find y equals 3, and then you tell me which x values it's 3 for, right? So if you look at this graph, notice here's y equals 3, but it's open, so we won't include that one. But here's another y equals 3, and it occurs at x equals 4. So we would say at x equals 4. It's asking you for the location that the y value is whatever it is. It's asking you for where it's located at. Okay, and then G says find all the x for which f of x or y equals 1. Okay, so notice that's a little bit harder of a question because we have a steady flat piece or a constant piece at 1. So if you wanted to say when is x equal to, or y equal to 1, you would say for x from, it looks like -2 to 2. Okay, notice I included -2 and 2 because it is actually equal to 1. The y is equal to 1 at those spots. All right, x-intercepts. Okay, nothing really to solve here, you just need to observe, right? So where does it cross the x-intercept, or x-axis, I mean? Notice it never does. So the answer here is just none. I'll go ahead and circle this guy too. And then lastly for this one, the y-intercept looks like it is 1. So we're going to write this as a point, so it's 0, 1. Okay. Something I didn't ask you on this one is this picture a function, right? And it would be because it would pass the vertical line test. Okay, so let's look at number 10. So before we get into the details of number 10, remember with domain we have 2 rules we don't want to break. We can't have x, not x, we can't have 0 in the denominator. And number 2, we want positive numbers only under a square root. Okay, that's what we want to happen. So for part A, f of x equals 2x over x squared minus 9. We want to find out what x values wouldn't be allowed, but then we're going to assume that it could be anything else. So we're going to set the denominator basically not equal to 0, if you will. So this is a difference of squares. This is the only thing you're going to be asked to really factor on this test, but this works out to be x plus 3, x minus 3. Okay, so it looks like x can't be -3, and x also can't be 3. Okay, but you're going to need to list these in interval notation. Okay, on the test I'll be more specific about what I want, but just assume I always want interval notation when possible. So here's -3 and here's 3. Notice we want to kick out -3 and 3, but we want to include everything this way, everything in between, and everything that way. So the domain is going to be -infinity to -3, -3 to 3, and then 3 to infinity. All right, so what about b? F of x equals the square root of 2 minus x. Notice this time we're worried about the second rule being broken, right? We want to only include positive numbers under the square root. So this is always how you set these problems up. We want this to be greater than or equal to 0, okay? Because this means that they will be positive. Okay, so that's why we set that up. And then we'll just solve from there. So if we subtract 2 from both sides, we're going to get -x is greater than or equal to -2. But I don't particularly want -x, so I would just divide by -1. But remember, when I do that, I have to flip the inequality sign, so this would be x is less than or equal to 2. So again, we can have a number line here that I think is helpful, but I'm not going to go so far as to require it. But we want 2 and everything less than it. If it were greater than, we would have traveled to the right. Okay, but the domain that I want to see is the interval notation version, so it'll be -infinity to 2, including 2. Okay, and remember, you can pick some values and try them out. In other words, like, pick some values you know are to the left, like 0, right? If you plug in 0 here, you're going to get square root of 2, which is fine, right? Notice if you plug in something to the right of 2, though, we become not okay, right? 2 minus 3 is a -1, and we can't take square roots of the negative numbers and get real results, right? So this looks like it checks out. Okay, so you can kind of check your work when you're taking your test if you're a little unsure. Notice for part C, I'm worried about both rules being broken, right? Okay, so notice that's exactly the same one that I just did, okay? So notice on the one hand, I want to make sure that the denominator doesn't equal 0, okay? So that means x is not going to be able to be 2. But on the other hand, I want to make sure that I'm taking the square root of positive numbers only. So I want to make sure 2 minus x is greater than or equal to 0. But notice I already did that, right? So what did I end up getting? I ended up getting x is less than or equal to 2. Okay, so I need some way to discuss both of these. Okay, notice they're kind of related to each other if you think about it. So here I have 2, and I want to make sure that 2 is not included. But then here I'm saying include 2 and everything less. So in other words, what this means is basically we have an open circle going back this way, because 2 had to get eliminated because of this one right here. Okay, so it looks just like this one. It's just that we're kicking out 2 itself, because 2 itself would give us a 0 in the denominator. In other words, it doesn't mess up the root part, but it does mess up the denominator part. Okay. And then lastly for this one, note that this is just a polynomial with no denominator, no square root, so there are no restrictions on x. So I put this one on here just so you don't overthink these. If there's no restrictions on x, then the domain is all real numbers. And remember, we write that as -infinity to infinity. So in other words, if you can't find something that x is not allowed to be, then x is probably allowed to be anything at all, okay, like it is in part D. Okay, so let's look at the next one. All right, so for number 11, notice all I asked you to do is describe to me what would happen. I'm not specifically asking you really to do the graphing, okay? So make sure you could describe what's going to happen, but also if you were asked to sketch a graph, make sure you can. So for part A, notice that we have f of x equal to 1 over x minus 2, okay? So remember, this is the handout that I gave you. So you need to know what are the parent function graphs, and then what transformation is being applied, right? So the parent function is y equals 1 over x, okay? Or we could call this the reciprocal function. You need to know either the name or what the equation looks like. Okay, but notice that we have a -2 on the inside. So notice this is on the inside, right, which means it's a horizontal shift, so this would shift right 2 units. So that would be your description. It's the reciprocal function slash y equals 1 over x, but it's shifted right 2 units. Okay, so you need to know two things. What does the original look like, slash what does the parent function look like, and then what change is being made. Okay, so notice for this one, the parent function I think is more obvious. So the parent function is y equals x cubed, or the cubic function. Okay, but notice this time the +4 is on the outside. And when it's on the outside, it represents a shifting up or down. So this would be a shift up 4 units. Remember that horizontal shifts work in the opposite way that we might have expected, which is why we shifted right 2 when it was negative. But vertical shifts work just like we would expect. So a +4 is going to shift it up 4. So you would just say shift it up 4 units. All right, so let's look at the rest of these. So we have f of x equals negative square root of x. Okay, so first of all, the parent function, in other words, the simplest form of this version of an equation would be just plain old y equals square root of x, okay, or the square root function. And a negative sign to the front, so notice how this is in the front. So if it's in the front, then it reflects over the x-axis. Okay, so it's a square root function reflected over the x-axis. Remember that like in visual form, it means that it got flipped upside down. D is f of x equals the cube root of negative x. So notice how this is different. Okay, the first thing is it's a different type of function, right? So this time the parent function is the cube root function, or y equals the cube root of x. And remember that has a different look to it, right? Remember the square root function is a sideways half parabola, whereas the cube root function is not a half, it's a sideways full cubic function. So notice how this is on the inside. Okay, so that means it reflects across the y-axis. Remember that these transformations can be learned in pairs, so it's helpful if you kind of do the shifts first, either horizontal or vertical, and then also do the reflections together because they're kind of paired up. So this would be reflected over the x-axis. Or y-axis, I don't know what I just said, but I meant to say y-axis. So remember we learned 6 total transformations, and the last 2 we talked about were the most difficult. Okay, so I have 3 x squared, so the parent function is going to be y equals x squared. Remember, these are called quadratic functions. Anything squared is called quadratic. Okay, notice we have a 3 in the front. Okay, so when you have a constant being multiplied in the front, it changes the height. So this is how you officially say this. We vertically stretch it by a factor of 3. Okay, if it would have been 1/3, we would have said vertically shrink it by a factor of 1/3. So this is going to be vertically stretched by a factor of 3. In other words, 3 times taller. So make sure you understand what vertical changes will do. It'll either make it taller or shorter. And then last but not least for this one, notice that for this function, by the way, notice I tried to do like varied functions here, okay? So notice this is the absolute value parent function. So the parent function, or the simpler form of this version, would be y equals absolute value of x, or absolute value function. So make sure you know in your mind, what those look like when you graph them. They look like V's, okay? So notice how this 1/2 is on the inside. Okay, so we are going to horizontally change the graph. And remember, these are opposite of the way you might think. So this is actually a horizontal stretch. So I'm going to underline the stretch part, okay, by a factor of 2. Essentially, you just flip the fraction, and that'll tell you what it's horizontally doing. So remember, the horizontal changes are the oddballs. The horizontal changes work in the opposite of the way you might think. The shifts go in the opposite way, and the stretches and shrinks do too. Okay, so another way to say that is it'd be twice as wide. Okay, so by the way, if that would have been a 2, then you would have flipped that 2 and it would have been half as wide. Okay, so that's what I mean when I say they work a little differently than you might expect. Okay, so for 12, I'm just going to kind of briefly talk about what we would do, okay? And then you can look at the key to kind of get what those look like in picture form, because I don't want to spend the time to sketch the graph when I've already done it on the key. Okay, just know that we need to change the y's, right? This is a vertical stretch by 2. Okay, so what this means is you're going to need to multiply the y's by 2. Okay, you do nothing to the x's. Okay, so if you look at your key that I'm going to send out a little bit later, you'll see how that's true, but this is the way that it looks. And again, you don't need to try to sketch this, but notice here's the original I did in pencil, right? So on your key, it's going to look a little bit lighter. And then notice everything's just double the height. Notice the width is still the same. Okay, so double the height, but everything else stays the same. So for B, same thing. I'm not going to graph it. So notice that this is on the inside, okay? So that means that we are horizontally changing it, and remember we have to flip it. So it's a horizontal shrink by 1/2. Okay, so if you flip 2, you get a half, okay? So in other words, you're going to either divide the x's by 2 or multiply them by 1/2, either way. Okay. So again, notice you're going to get this on your graph, but notice the pencil is the original, okay, the lighter one is the original, and the new one is the same height, it just got squeezed in, okay, it got, the x values were literally halved. So then, last but not least, for this one, okay, we have, remember that we have an order that we need to do things in, so we're going to not only list what's happening, but we're going to number them. This is going to shift it down 3. This is going to shift it left 2 because it's on the inside. This negative sign in front is going to reflect it over the x-axis. Okay, and remember you kind of work from the inside out. So you do inside first, then you kind of work your way out from there, and you follow with this one. So you need to take every point and do it left 2, then reflect it, then go down 3. Okay, so we did some of these in class, so make sure you go back and look at your notes. But again, I'm going to show you the key that you're going to get a copy of, and I'm just going to practice it for 1 point. Okay, notice that here, right, we want to, I forgot what I was doing. We want to go left 2, right, and then we want to reflect it over the x-axis, but notice it's on the x-axis, right? So we leave it alone, and then we go down 3. Okay, so let's do this one since that point didn't actually reflect. So for this one, we're going to go left 2, and then we're going to reflect over the x-axis, so that's going to put us at -2, and then we're going to go down 3. Okay, this one, we're going to go left 2, flip over the x-axis, right here, sorry, and then go down 3. Okay, same thing everywhere. Notice that it is just a flipped version of this one. We didn't change the height because none of these changes affected the height or the width for that matter. Okay. Okay, so moving on, let's look at number 13. So determine whether it is x-axis, y-axis, origin, symmetry, or none of these. Okay. On the test, expect that you will not get any credit for a random guess. Okay, so let me repeat myself. No credit for a random guess. You're going to have to show some work. Okay, so for this one, we actually have 3 different formats. We want to see, does it have any of these types of symmetry, or maybe a combination of a couple of them, maybe none of them. Okay, so remember, for x-axis symmetry, we set y equal to -y. Okay, for y-axis symmetry, we set x equal to -x. And for origin symmetry, we set both x and y equal to -x and -y. So I think you should be able to remember that. Whatever type of symmetry you want, you set the other thing equal to the negative version, and then for the origin, you just do both. Okay, so we get -y equals x to the 4th minus 3 here. Okay, when you simplify, try to make it look like the original. In other words, we want this to look like y equals. So notice we divide by -1, right? So we get y equals -x to the 4th plus 3. And then what you're supposed to do is you're supposed to compare this. Compare to the original. Okay, and notice that it is not the same. So if it's not the same, then it doesn't have that kind of symmetry. Okay, so it has no x-axis symmetry. Okay, so this is similar to what I'm going to want to see work-wise on your test. Okay, so let's do y-axis symmetry. So it's y equals -x to the 4th minus 3. So notice here we have y equals, if you raise a negative thing to the 4th power, you get a positive thing. And then you're going to compare. So compare this to the original. Notice it is the same. Okay, so since it's the same, it means it has y-axis symmetry. And then lastly, we do it for both. So -y equals -x parentheses to the 4th minus 3. So do the exponent first, right? And we're going to get x to the 4th minus 3. And then similar to what we did in the x-axis symmetry one, if you make this look like y equals, it doesn't look like it's going to be the same, right? All the signs are going to change. Okay, so I'm just going to say not the same as the original. So since it's not the same, it has no origin symmetry. So I think we did one in class originally that had like all 3. This one in particular just has one of them. Okay, but just know that all combinations are possible. All right, so let's look at B really, really fast. So x equals absolute value of y plus y squared. So again, I'm going to make this quicker because we just did one like this. In other words, I'm not going to write my process this time. So for y-axis symmetry, we replace x with -x. So, or sorry, we replace y with -y. So we're going to have x equals absolute value of -y plus -y squared, and then simplify. So x equals, notice it's absolute value, so that would change to a positive. A negative times a negative is a positive. Okay, notice it is the same. So yes, for this one, yes, it has x-axis symmetry. Okay, so I'm being more brief with this one because you've already seen one where it worked all the way through. Y-axis symmetry, go ahead and replace x with negative x, but leave y alone. And then we would make it look like as close to the original as possible, which would mean all the signs would change. So x equals negative absolute value of y minus y squared. Okay, so it's not the same, so it's a no. Okay, I'm going to be checking your work on these, so I need to see that you plugged in the negative version and that you actually worked it out after that. And then negative x equals absolute value of negative y plus negative y squared. Okay, so notice if you do what you're supposed to do first, which is the absolute value and kind of the square root, you're going to get both of these become positive. But then you're right back to where you were on the last one, right? When you divide by negative 1. It's going to change too much, right? It's going to be x equals negative absolute value of y minus y squared. So not the same. So it's a no. Okay, so both of these only had one answer, but just know that on your test, don't stop when you get one yes, because remember it can be a combination of a couple yeses or maybe all 3 yeses. So that's how you determine symmetry. Expect a problem or two about that. So remember, even, odd, and neither. Remember, for this one, it's the same for all. You replace x with negative x, okay? And if it's the same, it's even. If it's the negative version of the original, it's odd. And if neither one of those things happen, it's neither. Okay? So for number 14, A is y equals, no parentheses, right? Just negative x cubed plus 2. Okay? So basically, you would kind of think of that as f of x equals negative x cubed plus 2. Remember, f of x and y are interchangeable. So I want to see this on your test where you replaced x with negative x. So negative x cubed plus 2. Okay. Do not cancel that double negative. You have to do exponents first. So negative x cubed would be a negative x cubed. Okay. And then it would cancel with that negative. So it just doesn't always work that way. So make sure you actually do exponents first. Okay. And then you compare this. Okay, compared to the original, okay, notice that it is not the same, which means it's not even. But also notice that it is not the negative version. So it's actually not odd. And the reason I'm saying it's not the negative version is if you compare these, notice the x changed sign, but the 2 did not. Okay, so since all the signs didn't change, that means it's not either one. So it's neither. B is y equals the square root of 4 minus x squared. So again, that means it's f of x equals the square root of 4 minus x squared. So we just write it in f of x notation. So I want to find f of negative x. So it's the square root of 4 minus negative x squared. So do the exponent first, right? Notice negative x times itself is positive x squared, so this would be 4 minus x squared, okay? And then you compare it. Okay, and notice it is the same, so it's even. So just like the previous one, you've got a 1 in 3 shot of guessing it right. Guesses aren't enough for a college math class, okay? So guesses are going to get you no points, like absolutely 0 points. So make sure that you can show the work and back yourself up. Okay, number 15, I just asked you a question, but no, on the test I might actually show you a picture of the graph. Remember that even functions have y-axis symmetry. So if you see a graph that looks symmetrical around the y-axis, then you know it's even. If it's odd, it has origin symmetry. And then, of course, neither functions. I'm not going to say it's not symmetrical. It just has neither of these types of symmetry. Okay, number 16, I really don't want to write out this whole equation, so I'm not going to, okay? So I'm just going to let you look at your review. But we have 3 equations, and you just need to decide which equation you should be using for all of these. Sorry about that. Okay, so before you go to plug it in, you need to make sure which equation it would be appropriate to use, okay? And you use the value of x that they gave you, okay? So notice -4 if you go to your equation, so this is what I am being lazy and don't want to write down, okay? You've got this on your review. Notice that -4 is less than -1, so you would use equation 1, and then you just plug it in, okay? So it would be -4 times -4 plus 2. Make sure you keep your signs straight, so that's 16 plus 2 or 18. Okay. For part B, we want f of -1. Okay. So again, go back to this equation. Notice that -1 would fall in the second category, right? Because this doesn't actually include -1. -1 is included here. So we would use equation 2. And so you would plug in -1 to the x squared equation. So it'd be -1 squared, which is a positive 1. Okay, I should not see you plugging it into more than one thing and then making a decision at the end. You make a decision on which equation to use right off the bat. For part C, we have x equals 3. Okay, so you have to ask yourself, is 3 greater than 2, or is it somewhere between -1 and 2? Notice it's greater than 2, right? So we would use equation number 3. Equation number 3 is not very interesting. It's just always the answer 5. And then last but not least, f of 2 is going to be plug in 2, and notice that would fall under equation 2 again, because 2 is between -1 and 2. So we would just do 2 squared and get 4. Okay, so for these piecewise functions, which is what 16 and 17 actually is, you just plug it into whichever part of the equation is appropriate based on the x you're given. Okay, so for this one, I'll go ahead and write it out. So notice we are going to be graphing a line and then a parabola. It is helpful if you make note of this to yourself so that you graph them correctly. And remember, how we do that is we come up with an XY chart for both of them. Okay, so this is for x's less than 0. This is going to be the line. And this is for x's greater than or equal to 0, and this is going to be the parabola. Okay, but remember, wherever you have a changing value, like it changes from one equation to the other, you actually need to include that in both places. So for this one, I would probably include -2, -1, and 0, but I'd make the note that, hey, this is going to be open since 0 is not actually included, but I need to get all the way up to that point. Okay, so we plug them in. So -2 times -4 is 8, minus 3 is 5. -4 times -1 is 4, take away 3 is 1. 0 minus 3 is -3. So you have a prettier graph on your paper, on your review. So I've got 0, -3. Oh, but I forgot to make that open. So 0, -3 is open, and then I've got -1, 1, and then 2, 5, -2, 5. -1, 1 is here. What did I do? Off. Oh, is that wrong? -2, 5. That really doesn't look like a line, does it? Oh, that's because I'm being goofy. So notice 0, -3 is here, not where I put it. Okay, and then -2, 5 goes here. So just like we thought, we have a line. Notice the mistake I just made, though. Me knowing that I was expecting a line helped me fix that problem before it became a real issue. Okay, so it's helpful if you do that. For this one, I'm going to pick a couple things, including 0, but a couple things bigger. So I'm going to get 0, 1, and 4. So I get 0, 0 closed, right? I get 1, 1, and then I get 2, 4. But then I know this one is a parabola. So notice, just like I expected, I have a line and then followed by a parabola. We did one in class that was, back when we were learning this, that was like they overlaid on top of each other. So that can happen, but in this case, it looks like they're just separate. All right. Sorry about that, I had tech issues. All right, so let's look at the last few questions. And I may have to start another video. In fact, it looks like I'm going to, because it'll only record an hour at a time. So let's do this next question, and then we'll go to another video for 19 through 21. So we want the relative maxima or minima. So remember, relative maxes are just the max in a certain interval. Okay, so the relative maximum, if you look at this graph, and again, I'm not going to draw it because you already have it drawn in your review. Okay, so notice that we don't have an overall max, but it looks like this point right here would be a relative max for the middle of the graph. So you would say it has a relative minimum of 0 at, sorry, that's for max. It has a relative maximum of 2 at x equals 0. Okay, and then notice we have kind of 2 tied for the min. Okay, but we have a min at 0 at either, it looks like x equals -2 or at x equals 2. Okay, so typically you're going to see max and mins written in that way. Okay. Okay, so I'm going to stop the video and then I'm going to start a new one so that we can finish out the last 3 problems.